Hello friends of EduMath. In this video, we are going to use the equations of motion in solving problems which involve a body moving on a straight path. And if you are new here at EduMath, consider subscribing and hitting the notification bell. For now, let us get started with a guiding question. A stone slides in a straight line across a horizontal sheet of ice. It passes a point with a velocity of 14 meters per second and the point B 2.5 seconds later, assuming the retardation is uniform and that the distance between A and B is equal to 30 meters. So we have to start by having a sketch, a diagram here. We have a stone going to slide from point A, and at point A it has a velocity of 14 meters per second. So at this point, if we are to move in this direction with a constant retardation, I can call it A meters per second squared. So at this point A, it means we shall have the initial velocity which is equal to 14 meters per second. Then it hits point B. Point B can be around there. After a time t which is equal to 2.5 seconds. Also, we have been given that the distance between A and B, that's the displacement AB, can call that. This here is equal to 30 meters. Part A, they need us to find the retardation. Now, we shall have to extract the information that we have. And before we extract the information, we have to know that if this body is moving with a uniform retardation, there will come a time, much as it will pass point B, but there will come a time whereby it will have to stop. So this is the stopping point. Okay, so at the stopping point, the velocity of the body is 0 meters per second. So let us check on what is given. I have been given the initial velocity u, which is equal to 14 meters per second. We've been given the distance between A and B, 30 meters. We have also been given the time t, which is 2.5 seconds. We need to find acceleration. Alright, we have to look for a suitable equation to use in finding this value of retardation. So our equations were v is equal to u plus at, and the displacement is equal to ut plus a half at squared. Also had this third one, v squared, being equal to u squared plus 2as. Now we have to choose the suitable one which has this information here, and we use it to get the retardation. Retardation is a negative acceleration, or retardation is the same as a deceleration. So according to the data we have, it means we are going to use this second one. We have u, we have t, alright, we have the s, we need to find a. So using displacement which is equal to ut plus a half at squared, we can now substitute in. We shall have 30 being equal to u 14 times t. Can write this in terms of an improper fraction. So this will be 5 all over 2 plus a half times our acceleration which we need to find. Our t is now 5 all over 2 power 2. Right, simplifying this by 2 ones by 2 7, so this is 30 being equal to 35 here, plus and this will be 25 all over 8a. So on simplifying, our a is going to be a value which is negative 1.6 meters per second squared. So we have got the value of the retardation, right? And this retardation is a constant or a uniform retardation. So throughout the motion, this here is the retardation. So we are moving to part B, where we are required to find the velocity at B. So if you are looking at this line segment from A to be, it means that we are interested in finding the final velocity. Okay, so let us look at what we have, and then we make our judgment on which equation to be used. We have the distance, which is 30 meters. We have the acceleration, which is negative 1.6 meters per second squared. We have the time, t is equal to 5 all over 2 seconds. We have the initial velocity, which is 14 meters per second. Required is velocity at b. Now, since we have u, we have a, and we have t, getting back to these equations, it means we can use this first one. We have this, we have a, we have t. We need to find the final velocity at b. If we are looking at this line segment a, b, so using v being equal to u plus at, we shall have v at b being equal to u, which is 14 plus negative 1.6 times our t, which is 5 all over 2. So velocity at b, if you have to simplify this, 14 plus negative 4. And at the end of the day, velocity at b is going to be equal to 10 meters per second. And we are done. Part C. How long after passing A, the stone comes to rest? So how long does it take to move from A to this point? Already we know that the stone is coming to rest. That means the final velocity at the point where it stops is 0 meters per second. We have initial velocity and we need to find the time, how long. So that means we are still going to use the first equation. Let's see, shall use v is equal to u plus at. So at the point where this body will be resting, the final velocity is 0, being equal to our initial velocity is 14 plus our acceleration negative 1.6 meters per second, and we need to find that time t. So this implies we have 1.6 t being equal to 14, and t is equal to 14 divided by 1.6. So when you press this on our calculator here, 14 divided by 1.6, the answer is 8.75 seconds. We have another example that we are going to have on the next page. A car is being driven along a road at a steady 25 meters per second. So let's have a road here. So it is being driven at steady 25 meters per second. When the driver suddenly notices a fallen tree, it was coming from this side. So when he reached this distance, okay, he suddenly notices a tree that has fallen ahead, 65 meters ahead. From this point where he notices to where the tree has fallen, we have there 65 meters. This is where we have the tree. So when the driver noticed that there is a tree that has fallen 65 meters ahead, the driver immediately applied the brakes, giving a car a constant retardation of 5 meters per second squared. So the acceleration here, this implies it's going to be negative 5 meters per second squared because it is a retardation. Okay, retardation is negative acceleration. All right. How far in front of the tree does the car come to rest? So this car will not come to rest exactly at the point where the tree has fallen. So that means the car is going to rest somewhere here. And where it rests, the final velocity is going to be 0 meters per second. Right? Now they need how far in front of the tree. Meaning that they need us to find this distance here. This distance, I can call it S. Okay, that is the distance they need us to find. So first let's extract out the information that has been given to us, then we make a judgment on which equation to be used. So we have u, which is 25 meters per second. We have acceleration, which is negative 5 meters per second squared. We are now going to be looking for this distance here, the distance between where he notices that the tree has fallen to where the car stops. And then we shall subtract that distance from 65 to get s here. Okay, so I can call it st. S small t is what we meant. We do not have the time taken for this car to come to rest. It's not there. We have the final velocity when it comes to rest. V is going to be 0 meters per second. So which equation should we use? We need to find this s first, using v squared being equal to u squared plus 2as, v which is 0 squared being equal to u which is 25 squared plus 2 times our acceleration is negative 5 st. That's the distance between here and here. So our aim is to find st. This is 0 being equal to 625 minus 10 st. So when you calculate st, is going to be equal to 62.5 meters. So the distance from here up to here is 62.5 meters. But the question wants us to find how far in front of the tree does the car come to rest. So that means we are looking for the distance s. So s is going to be equal to 65, this from here to here, minus from here to there, minus 62.5. So the distance s there is going to be equal to 2.5 meters. So the car will stop 2.5 meters ahead of the tree. Part B says if the driver had not reacted immediately and the brakes were applied 1 second later, with what speed would the car hit the tree? So this car was traveling at 25 meters per second. Let us see. If the driver doesn't, react immediately, that means he's going to travel that distance using this speed here. He's going to travel a certain distance using this speed here in 1 second. So we need to first of all find this speed, and the rest will act like what we have been looking at here. So the t here is equal to 1 second. All right. We now need to find the s, the distance which is traveled between here and here. Now, since it was a steady speed, that means the acceleration between here is 0. Not until after 1 second, when he realized that, oh, there is a tree which has fallen ahead. That's when he started applying brakes and changing the speed. So here, acceleration is equal to 0 meters per second squared. So using s being equal to displacement is equal to ut plus half at squared. Acceleration is 0 in that gap there. So we are now remaining with getting the displacement, the distance it travels within that delay of 1 second. So this is going to be 25 times time, which is now 1 second. This implies that in that delay, this driver was able to move 25 meters. So from here to here, we have 25 meters. Then after that, this driver applies the brakes, meaning that the initial velocity at this point is still 25 when he started, applying the brakes at this point here. It means his speed started changing after 1 second here. Okay, so which distance are we remaining with? The whole distance from here up to here is 65, and we have taken off the 25 meters due to the delay. So how much distance are we left with that the driver has to, move until he reaches the tree? So we are going to get 65 minus this 25 to get the distance which is remaining. So remaining distance is going to be equal to 65 minus 25, and this gives us 40 meters. That's the distance that is remaining. They need us to find the speed with which the car hits the tree with. Okay, yes, that's what they need us to find. Now we have u, which is 25 meters per second. We have the displacement, the distance it has now to move, which is this one, 40 meters. We have the acceleration, it is a constant retardation, so we have negative 5 meters per second squared. Then we are looking for v, the velocity or the speed with which the car hits the tree with. So based on this information that we have, we are going to use the third one, using v squared being equal to u squared plus 2as. We substitute, we have v squared being equal to, our u is 25 squared plus 2 times our acceleration, which is negative 5, times the distance which it has to travel, it is 40 meters. So when you simplify this, v squared is equal to 625 minus, this is 10 times 40, 400. So when you subtract, v squared is going to be equal to 225. Taking the square root, v is going to be equal to 15 meters per second. So this is the velocity with which the car hits the tree with. Okay, so I would like to thank you, my viewer, for being with me up to this point. I would like to leave you with one number that you will try on your own. So here is our number, my dear viewer. Make sure you pause the video to copy that question, and you also give it a trial. For now, we would like to thank you very much, and we say God bless you.